All right, welcome to 9.3 part 2. It's an extension of part 1. We're going to continue looking at polar expressions but with complex numbers. So today, take a quick pause here to read through this. This is on the note sheet, but pause here. Otherwise, I'm going to move on. These are what our goals are going to be. Yesterday we learned about the z equals r cis theta, right? Remember, cis is the cosine plus I sine theta. And so here what we're going to look at is multiplying and dividing two complex polar numbers, right? And so we have these formulas here. If z1, if this is the first one, and if z2 is the second one, then we have these following formulas, all right? Please take note of what these formulas are. Okay, so for example one, okay, we're just gonna we're gonna go ahead and multiply these. But before I do, I'm gonna first label these. Right, so those are R1 and theta 1. Right, so when it says z times w, notice here we're gonna multiply the r's together. So whoops, 3 times 5, right? And then the cosine of, and then it says to add the angle measures. So theta 1 plus theta 2, that's 120 plus the 30, we know that's going to be 50. All right, so that comes from theta 1 plus theta 2. And the rest of it is going to be, that's going to be I sine of also 150. And then from here, we just evaluate it, all right? We know that 3 times 5, of course, is going to be 15. Okay. Cosine of 150, and just to make sure, right, we know that cosine of 150, I want to practice just putting it in radians for now. This is cosine of, what is this, 5 pi over 6 plus I times sine of 5 pi over 6. And then again, we keep evaluating. Cosine of 5 pi over 6, right? We know that's going to be, what is that? Negative root 3 over 2 plus I times sine of 5 pi over 6 is 1/2, right? So that's what we have so far. And then we distribute the 15, okay? And then we're done, okay? You could leave it here if you want. I would accept that. Or if you want to go ahead and distribute it, that's going to be negative 15 root 3 over 2 plus 15I over 2. Okay, this last step isn't necessary. If you want to leave it right here, I am okay with that. Right? So let's look at part B of this example. So it says to divide the two complex numbers in polar form. And so I've already set it up for you here. This is R1 divided by R2. And now we're doing R1 minus, or I'm sorry, theta 1 minus theta 2. Okay? What I want you to be careful of is right here, and I've seen this happen in the past, because we're subtracting the angles, people will subtract right here. That's not the case. That's always going to be positive, all right? And so, again, we work these out, right? 120 minus 30 is 90 degrees, and so our next line looks like this. And we evaluate these, right? Cosine of 90 and sine of 90. So cosine of 90 is 0, and then sine of 90 we know is 1, so that's just 1i, or just I, and 0 plus I is just I, so this is really just 3/5 I, and we're done. Okay, so those two formulas are important to know, all right? But what happens when you are given a rectangular form, right, like this one? Okay, so this is example number 2. This one is going to be a bit of a process, so I'm going to walk you through it here. Now the thing is, before we multiply z times w, we have to convert these to polar form, all right, into the CIS form. All right, so you have to first, that means we got to figure out the R value and what the angle measure is for both of these. So here are my two setups. All right, this is going to be for Z, this is going to be for W, right? For the Z, we have to figure out what R is, and we know that we can use the Pythagorean theorem here, right? This turns out to be 2 root 2, so that's the R value, all right? Then we also know that we need to figure out the theta, right? And again, you could use inverse sine or cosine. I'm noticing that these are the same. So if I do the inverse tangent, right, I know that's going to be theta is equal to, when it's the same on the numerator or denominator, theta is 45 degrees. And this is in quadrant 1. So 45 degrees is the same thing as pi fourths in radians. So there's my theta, all right? So therefore, this complex number in polar form is actually z is equal to 2 root 2, that's my r, and then my cis, right? Cosine of pi fourths plus I sine of pi fourths. Okay, that's what we have so far. And we're going to do the same for w over here, right? By Pythagorean theorem, we're going to figure out the r value. Here, the r value is 2. And again, we also need theta, the angle. Okay. Again, you could use sine, cosine, or tangent. I'm noticing maybe opposite over hypotenuse. That's a negative 1/2. We know that sine, right, from SOHCAHTOA. So sine of theta is negative 1/2. This is a familiar trig value, right? And so we know that the theta here must be quote unquote 30 degrees, right? But since we're in quadrant 4, this reference angle of 30 degrees is actually, if you go all the way around, right, that ends up at 11 pi over 6. Okay, so here's your R value, and here's your theta. That means W is written as the following, right, which is right here. Okay. Now we're multiplying these two numbers, right, the Z times the W, right, and looking at the formula at the top of the note sheet, or a couple slides ago or earlier in this video, we multiply these R values, okay, and then we're going to add these angle measures, all right. Now, so that's going to be Z times W is equal to the following. Right, this is the result of multiplying R1 and R2. This is theta 1 plus theta 2. All right. Now, I'm okay if you leave it like this. All right. If you want to clean it up a little bit, that's fine. If you want to add these two angle measures, that's okay. Then you would get the following. That's going to be 25 pi 12ths when you add those two angles. All right. So that's it right there. So then that leads us into part 2 of this lesson. Right, we're going to look at, I think I'm saying this right, I'm not sure, what's called de Moivre's theorem, all right? And that's just if we're adding an exponent here, right? Z to the nth power. And I'm saying it's an extension because Z, like for instance, this first example, right? Z to the third means Z times Z times Z, right? We could take our formula from the first part of this lesson. We can multiply Z times Z by itself using the formula, and with that result, we would multiply that with the last Z, right? But that could be pretty repetitive. And so de Moivre's theorem states this, right? Whatever your n is, your exponent, is r to the nth power, cosine of that exponent times the angle measure, right? And so I'm gonna work this out, right? Here I wrote the abbreviated version. This is what it looks like here. there it is in expanded form, and it says what is z to the third. So I'm going to, if it's a z to the third, then my r value gets raised to the third, and these 20s, right, get multiplied by 3. So really what I end up with is, and you can evaluate this right here if you want, that's going to be 8, that's z to the third, 8 times, right, cosine of 60 plus I times sine of 60. And at this point, you could leave it like this, all right? Or if it asks you to put it in rectangular form, then you would evaluate these, okay? If it does ask you to put it in rectangular form, then we're going to go through and work this out, right? The cosine of 60 degrees is 1/2 plus I times, that's going to be root 3 over 2, and then we distribute the 8, right? So that's going to be 4 plus, when this gets distributed, that's going to be 4i root 3. Okay, so this would be your answer if it asks you to put it into rectangular form. If not, then what's here in red would be complete, right? But again, sometimes you're going to be given rectangular form, all right? And then you have to convert it into the polar form, all right? Because we need the r value and we need the theta, okay? So here's what my setup is going to look like first of all, right? I'm in quadrant 1 because 1 plus 1i means 1 along this axis and 1 up along the imaginary axis, okay? And we do Pythagorean theorem because we need the r value, and that turns out to be root 2 in this case, okay? Then we need to figure out theta, right? And so theta, we know that, well, these are the same, opposite over adjacent, so I'm going to use tangent, right? And when it's the same, we know that's 45 degrees, or we know that's pi fourths. Okay, we're always going to use radians here, all right? So that's pi fourths, and so now, putting that all together, z is going to equal, right, root 2 cosine of pi fourths plus I sine of pi fourths. Okay, and we were asked what is z to the 5th power. Okay, so if we do z to the 5th power, okay, that's going to be root 2 to the 5th, and we're going to multiply the angle by 5, right? So that's going to be cosine of 5 pi over 4 plus I times sine of 5 pi over 4. Okay, now you could clean this up. One quick sidebar here is by exponent rules, when you have square root of 2 to the 5th, it's actually the same thing as square root of 2 to the 5th inside, square root of 2 to the 5th inside, right? So this is the same thing as square root of 32, okay? So you could clean that up, and the square root of 32, if you simplify that, that turns out to be 4 root 2, okay? 4 root 2 cosine of 5 pi over 4 plus I times sine of 5 pi over 4. All right? Now, again, if it asks you to put it in rectangular form, right, then you have to work this out, right? You have to evaluate what this is going to be. And so this is what you get, cosine and sine, and then we distribute the 4 root 2, okay? And you end up with negative 4 minus 4i.